example, we have the so-called Duhamel's principle. This principle will help us solving this initial value problem, or in general, we have this type ax double prime bx prime cx equal to f of t. So f of t is just a function in terms of t. So the left hand side here you have a equal to 1, b is 4, c is 3, and the initial conditions are x at 0, x prime at 0, I is 0. So this one we always have the initial condition x0 and x prime at 0 are 0. So here's how principle would work to solve this initial value problem. You first do Laplace transforms both sides. So let me do for the general case here. Laplace transform both sides, you have Laplace transform of the left hand side equal to the Laplace transform of the right hand side. So let's denote Laplace transform of small f is big F. So the right hand side is big F. The left hand side we can pull a, b and c out. So a Laplace transform x double prime, b Laplace transform of x prime, c Laplace transform of x. So now let's denote big X, the Laplace transform of small x. So now we have Laplace transform of x double prime. You can use a table. It is s squared times big X minus, I write s big X, minus s times x at 0, small x at 0, minus small x prime at 0. But the initial condition are all 0. So the only terms left is x squared, s squared times x minus 0 minus 0. Laplace transform of x prime, you can use a table. You see that this is s times x minus x at 0. And by using the initial condition, you know that this is s times x because x0 is 0. Laplace transform of small x is big X. We can rewrite this equation in terms of big X. So you have a times s squared times x, b times s times x, c times x equal to big F of s. So this is all x of s. You can group x of s out there. So inside x of s, inside you have a s squared, b s, c equal to big F of s. Now you can have big X of s is 1 over this one times big X, big F of s. And all we need to do is this function small x of t is the inverse transform of big X of s. So inverse transform this product. This function here, we call it the transfer function. The transfer function of the system we are working with. The inverse transform of the transfer function let's call that omega t, and we call this the weight function of the system. So you know that inverse transform of this term is omega t. Inverse transform of big F is small f. So now we can use a convolution. So xt is the inverse transform. Xt is the inverse transform of the Laplace transform of the weight function omega t times Laplace transform of the function small f, the function they give us, in the right-hand side of the system. The Laplace transform of ft. And this one is omega t star ft, so the convolution of omega and f. And by definition of convolution, this is the integral from 0 to t omega tau f t minus tau d tau. This one is a solution of this system, and the formula we just obtained called the Duhamel principle. Now let's use the Duhamel principle for our particular problem here. In this particular example, we do not have to memorize this. You can, if you don't remember this, you can redo on again, doing the Laplace transform both sides, and then you continue. Then you will get this convolution. But now we know the formula. We just do omega t, which is the inverse transform of this one. So I just use that. The weight function omega t is equal to this, equal to inverse transform of 1 over, in this case you have a, b, c, 1, 4, 3, 1 over 1 times s squared, 4 times s, 3. So this is the weight function. Now let's try to compute this one. Now this is inverse transform 1 over s squared 4s 4 minus 1. So this is inverse transform 1 over s plus 2 squared minus 1 squared. So we have k over s squared minus k squared, in this case k equal to 1. So this is a transform of sine hyperbolic kt. So our k is sine hyperbolic 1t. 1 over s squared minus 1 squared minus 1. Then you have the translation right here. So let's call this function big G of s. The function they gives us right here will be big G of s minus negative 2. Big G of s minus negative 2. 1 over s, we change s to s minus negative 2. S plus 2 square minus 1 square. So this one is the translation on the s-axis, right? So the formula is EAT times GT, where small gt is the inverse transform of big G s. So we have EAT minus 2t times gt sine hyperbolic t. This is the inverse transform we need to compute, which is omega t. This function is omega t. Now the Duhamel principle says that's the solution of the initial values problem right here. Xt is the convolution of omega t's ft. Xt the solution of the system is a convolution of omega t ft. By definition, integral 0 to t omega tau e to the minus 2 tau sine hyperbolic tau f t minus tau d tau. So this is the final answer for the solution of the initial value problem we have using the Duhamel principle.